You have any math questions for me? Did you look at any of the homework? Questions, stuff sheet? I'm going to go over, I'll probably do a couple of the first derivative test examples, which is 3.3, and then I'll do 3.4. Anything that you want me to talk about? No. Yeah. One more second. Okay, so let me do a couple of review examples, and then I'll do 40 afterwards, since 40 is a little more complicated than the ones I want to start with. So here's some review examples. The instructions for the most part for this section are to find the intervals on which the function's increasing and decreasing, as well as the relative max and relative min. Find intervals of increase and decrease. And all relative extreme. Okay, so let's see. Did I give you guys any trig functions last time? Oh yeah, we left off with x plus sine x. All right. So then let's do f of x equals x times the square root of 4 minus x squared. So here's my function. I want to figure out when this guy is increasing and decreasing, and what the relative extreme are, relative max and min are. So how do you find those things? What do you need to do? Derivative, right? Critical numbers. Critical numbers. You set the derivative to 0 and undefined. That's going to tell you how to set up your table or your chart. So how do I take the derivative of this guy? It's got to be product rule, because you have x times root 4 minus x squared. So let me rewrite this with a 1/2 power. This is x times 4 minus x squared to the 1/2. So when I do a derivative, I'm going to do a product rule. The product rule says do the derivative of the first times the second. So f prime of x equals the derivative of x, which is 1, times the second function, plus what?
1/2 4 minus x.
So then you keep the first function the same, multiply by the derivative of the second function. So the derivative of 4 minus x squared to the 1/2 says bring down the 1/2, keep the inside the same, subtract 1 from the power, and what do I need to multiply by?
2x.
Derivative of the inside. So negative 2x. Now, I want to find out, let me clean this up a little bit. Certainly this 1/2, this 2 on the bottom and this 2 on top can cancel. And I can rewrite this as x times x, which is x squared. So I'll have 4 minus x squared to the 1/2. Plus, well actually, x, but then there's a minus sign here too, so minus x squared, 4 minus x squared is the negative. And how can I simplify from here, do you think? There's kind of 2 routes to go, but I'm going to need to simplify this so I can set it equal to 0 and solve.
Negative x over 4 minus x.
Negative x over 4 minus
Negative x squared over 4 minus x squared.
So you can bring this down to the bottom and then get a common denominator. That's one route. Okay. The other route's to factor. Do you remember how to factor this? What can you pull out of 4 minus x squared to the 1/2 and 4 minus x squared to the negative 1/2? 4 minus x squared to the... When you're factoring, you always pull out the smaller exponent. So which one's the smaller exponent? Negative 1/2. So you can factor this guy, which is going to get us to our zeros pretty quickly, by pulling out 4 minus x squared to the negative 1/2. What would you have left after that? If you pull 4 minus x squared to the negative 1/2 out of 4 minus x squared to the positive 1/2, what happens?
4 minus x squared to the
4 minus x squared to the 1. Right? When you factor something out, you subtract the exponents. So if you take 1/2 and you subtract negative 1/2, you'll get 1. And if you pull 4 minus x squared to the negative 1/2 out of here, you just have minus x squared. So this guy will drop down to the bottom. And then what do you have left on the top here?
4 minus 2x squared.
So then as far as your critical numbers go, what do you have to do? Top to 0, bottom to 0, right? Where the top is 0, that's when f prime is 0. And the bottom is 0, that's when f prime is undefined. We get 4 minus 2x squared equals 0. This is when f prime of x equals 0. And then we get square root of 4 minus x squared equals 0 for when f prime is undefined. This guy we solve by adding. X equals plus or minus root 2. This guy we have to square both sides. Then we add. Then we square root. So these are my critical numbers. So what do I do with those if I want to know where I'm increasing and decreasing and where my relative max and relative min are? You got test. That's the test. So you have into your derivative, you test in between and beyond your critical numbers. So here's negative 2, here's 2, here's negative root 2, and root 2. Yeah, so these are your critical numbers. You have to test between these. So negative 3 is a good one. 0 is a good one. 3 is a good one. What about between negative root 2 and negative 2? 1 is actually less than root 2. Root 2 is like 1.41 or something. So I'm probably going to have to test 1.5. Oops. Negative 1.5. All right, so you get a decimal for root 2, and then you pick something between that decimal and 2. Now, you're gonna run into an issue here, and I hope it's not gonna blow your mind, but we'll see. So what happens when we put in negative 3? Right, because you take that number that you're testing, this is your test point, and you plug it into your derivative here. So what happens when you plug in negative 3 on top? Negative, right? Because you'll get 4 minus 18. What about when you plug in negative 3 on the bottom? Negative 3 squared is 9. 4 minus 9 is negative 5. Square root? What's that mean? Yeah, that doesn't make any sense. Square root of negative 5. This is the square root. That doesn't make any sense. So what's that telling us?
75.
Yeah, our function's undefined there anyway. All right, so this is not in the domain of our function. So we would usually test them, but they're not in the domain. So we don't have to, we can't. So if you start getting undefined when you're doing these tests, probably you weren't in the domain of f to begin with. It makes sense the same thing's going to happen with 3, right? Because you get 4 minus 9 again. So then what happens with negative 1.5? When you plug in negative 1.5 on top, negative 1.5 squared is 2.25. So 4 minus 2 times 2.25. Positive or negative? Negative. Same thing here. 1.5 squared, negative 1.5 squared is 2.25. So 4 minus 2.25, well, it doesn't matter. Square root's always positive, right? So these guys are negative. When you plug in negative 1.5, you got a negative over a positive. What about when you plug in 0? So do 0 squared here and 0 squared here. Top's positive, bottom's always positive, because when you take the square root, it's always positive. And then when you plug in 1.5, this is going to go back to negative. Right, because 1.5 squared is 2.25. 2 times 2.25 is 4.5. 4 minus 4.5. Okay, so we figured out these numbers weren't in our domain. Good for us. Yay, then we got minus, plus, minus. So how do we read our answers? We're increasing, decreasing, and then our relative maxes and mins. So what does the minus mean? Does the minus mean you're going up or going down? Going down. So here I know I'm going down. Then the plus means I start going up. And the minus means I go down again. So if I go, since I'm going from down, going down and then going up, this must be a min at negative root 2. Since I'm going from up to going down, this must be a max. And that's it. I'll stop here. So then, let's see. Increasing. What interval am I increasing?
2, negative root 2 to root 2.
So I'm increasing only when I'm going up from negative root 2 to root 2. I'm decreasing on the other two intervals, which will be from negative 2 to negative root 2. And then also from root 2 to 2. Now, as far as my relative min goes, I have the x value of my relative min, which is negative root 2. How do I get the y value? Where? The original. So you have to plug negative root 2 in here to get your y value. So f of negative root 2, the original function at negative root 2, is equal to negative root 2 times 4 minus negative root 2 squared to the 1/2. So this will be 4 minus 2. So this will be negative root 2 times 4 minus 2 square root. Since inside here is 2 again, and you get square root because of this, you just have root 2 times root 2 be negative 2. So my relative min will be negative root 2, negative 2. Relative max. So relative max is at root 2. Then you have to figure out your y by doing f of root 2. So you go to your original function, and you say root 2 times 4 minus root 2 squared. Root 2 times 4 minus root 2 squared is 4 minus 2. So this is going to be root 2 times root 2. Relative min was negative root 2, negative 2. Your relative max is negative, or is positive root 2, positive 2. Increasing. The ends of this domain are technically relative maxes and relative mins as well. Like if you stop here, then this point on the left would be a relative max. And if you stop going down here, then this point would be a relative min. So we can calculate what those are. It's kind of funny because you don't have anything else on the other side. But it's kind of like if you had a half circle. This isn't quite the graph, but if you had this picture, then this guy here is technically a relative min. And this guy here is also a relative min. That's what's happening in our picture. We're stopping, so this will be the highest point according to all the points around it. And this will be a low point according to all the points around it. So there should be another relative min or relative max in the end points. I forgot about the domain. But anyway, this is technically a difficult problem. Like the algebra is kind of tricky.
Let's start off with an easier one.
But let me ask you this: how did the factoring go here? Does this make sense, or should I show you the other way? Did you guys understand how I factored out the negative 1/2 power here or no? Yeah. So, quickly, if it didn't make sense factoring out the negative 1/2 power, how else could you How else could you do this? Right? If you rewrote these as roots, how could you combine these two fractions here? You need a common denominator. So if you don't want to factor, then you have to rewrite them as roots and get a common denominator. And what would you multiply this guy by?
Square root of 4.
Yeah, you need to get 4 minus x squared square root. So you put it here and here. So on the first fraction, this will become 4 minus x squared, because a root times a root will give you the thing underneath. On the bottom, it'll just be root 4 minus x squared. This guy won't change. And then you can combine these together. Right, 4 minus x squared is 4 minus 2x squared. And then the common denominator goes underneath. This is the same derivative we ended up at before. But when you're doing critical numbers, you are going to have to simplify your derivative. Otherwise, you won't be able to solve it equal to 0 and undefined. Let's do another one. So there's a function, sin x plus cos x. I want to know what the relative matrices are. I want to know what the relative extreme are and where it's increasing and decreasing. So what do you do? Take derivative. Right, if you want to know about increasing, decreasing, and relative extreme, you take the derivative. So at least this derivative is pretty straightforward, right? No product rule, no chain rule. Derivative of sine is cos x. Derivative of cosine is. There's no denominators here, so when I'm finding critical numbers, I don't care about undefined, all I care about 0. So for my critical numbers, I'm going to set cos x minus sine x equals 0. It's never undefined. How do I solve this?
Make cos x equal to sin x.
So I would, yeah, you can move over the sine x and do cos x equals sine x. Where do you go from there?
Just do 4.
Yeah, so one way is just to go look on your unit circle where sine and cosine are equal. Another way is to divide. You know that if you divide by cosine, this is 1 equals tan x. So then you look for all the places, well, you either use inverse tangent or you look for all the places where tangent is equal to 1. You should get, on the 0 to 2 pi though, you should get 2 answers. So either where is sine x equal to cos x, or where is tangent equal to 1? From 0 to 2 pi. Pi in the, yeah, you have 2 quadrants, right? Tangent's going to be positive 1, either here or down here. So our 2 critical numbers are x equals pi over 4, or x equals 5 pi. So then we test. Here's pi over 4. Here's 5 pi over 4. 2 pi. 0. There we go. So I have to test in between. Okay, so I would probably use angles that I know the sine and cosine of really easily. So for example, less than pi over 4, I can use maybe pi over 6 would be a little better. And then between pi over 4 and 5 pi over 4, there's a lot.
Pi over 3, pi over 2.
Yeah. Between pi over 2, those are all easy. And then between 5 pi over 4 and 2 pi, probably 3 pi over 2. So on the unit circle schematic here, I pick this angle, which is less than the first answer. I pick this angle, which is between the first answer and second answer. And then I pick this angle, which is bigger than the last answer. So what happens at pi over 6? Where are we plugging this in, by the way? First derivative, which is right here. So cosine of pi over 6 minus sine of pi over 6. First test. You know what cosine of pi over 6 is? 3 over 2. So root 3 over 2 minus 1/2 is positive. Right? Root 3 is bigger than 1. So this will be positive. What about pi? Cosine of pi minus sine of pi. Cosine of pi is -1 minus 0. So negative. Pi over 2. Positive, right? Because cosine of 3 pi over 2 is the x value, so it'll be 0 when you're down here. Sine of 3 pi over 2 will be -1, so 0 minus -1 is positive. So that means my function's going up here, and it goes down to here, and it goes back up after 5 pi over 4. So I'm going to have a max at pi over 4, a min at 5 pi over 4. What about increasing, decreasing? So I'm increasing on what interval?
0, 0.
Where the first plus sign, since I told you to start at 0, this will be from 0 to pi over 4. Increasing, decreasing are always parentheses. But then I'm increasing again from 5 pi over 4 to 2 pi. Because that's where I am. Decreasing in between pi over 4 to 5 pi over 4. Relative max has an x value of pi over 4. How do I find the y value? Plug it into the original, f of pi over 4. Here's my original. So I have to do sine of pi over 4 plus cos of pi over 4. So sine of pi over 4 plus plus cos of pi over 4. Root 2 over 2 plus root 2 over 2. Just equal to root 2. There's my relative max. Because when you add these together, you get 2 root 2 over 2. And 2's cancel. Then my relative min is at 5 pi over 4. For the y, I plug it back in. It's going to happen when I plug 5 pi over 4 in here. They're both going to be negative because it's down in the third quadrant, so you get negative root 2 plus negative root 2, which will be negative root 2 over 2 plus negative root 2 over 2, which will be negative root 2. Yeah, so there's another technicality here. But before I talk about that, questions about taking the derivative 7 equals 0 testing? Any questions about what I did? I know I kind of flew through this evaluation, but I'm praying that you can plug pi over 4 in and get this root 2. If not, let me know. These are my actual tests here. Now, because I have a closed interval, so you'll notice I put, I don't know why I did this, but I did this. We'll talk about it. I put a closed interval 0 and an open interval 2 pi. The open interval means I never actually get here. Okay, so I'm not going to have, whatever my function looks like, I'm not going to have a relative max on the right because I never get to that final point. But on the left, I have a closed interval. Which means on the left, as I come down here, my function is going to, at 0, it is going to get to a point. So this is technically another max or min? Min, right? Because it's lower, there's nothing on the left according to my domain. According to the interval I picked for my domain, there's nothing on the left. And everything on the right is higher than. So this is a relative min. So the endpoint gives you a relative min at 0, 1. I'm kind of glossing over this because I'm probably not going to ask you one like this. I'll either put them both open intervals, or I won't. Both open parentheses, or I won't give you an interval at all. But if you do have a closed interval like this, and you're going up after that closed interval, this is a min. Okay, and this will be at 0, 1. Because when you plug 0 in, you get 1. This is from the endpoint. It's always the same principle. Take the derivative of 7 equals 0 and it's fine. It just gets annoying, right, when you have to plug all this stuff in. So if you can survive the annoyingness of it. I want to look at, I guess, 40. So number 40 in 3.3 gives you a piecewise function. It says find the critical numbers, find the open intervals on which the function is increasing, decreasing, find our relative extrema, and then use a graphing utility to confirm your result. So let me write down the function over here. It gives you f of x, this is from 3.3. piecewise function. Negative x cubed plus 1 if x is less than 0. Oh, less than or equal to. And then it says negative x squared plus 2x if x is greater than 0.
Give me a little thing. Thank you.
So to find my increasing, decreasing, and my relative extreme, I got to do derivatives. But because I have a piecewise function here, I'm going to have to do the derivative in pieces. And then I'm going to have to worry about what happens at 0, right? Where I put these together. So let's talk about for x less than or equal to 0. What's my derivative look like? Let's do less than 0 actually. Open interval. So if I'm less than 0, so away from the point 0, on the left of the point x equals 0, what's my derivative? Yeah, so away from the point 0, on the left of the point 0, my derivative comes from this formula. Because this is the only formula that matters left of 0. What about for x greater than 0? F prime of x come from this formula now. So negative 2x plus 2. What do you think happens at 0? Yeah, so a couple of things. First of all, at 0 the function's not continuous. How do I know the function itself is not continuous at 0? If you plug in 0 here, you get 1. If you plug in 0 here, you get 0. So whatever's going on, this guy's going to 1 when x is 0. This guy's going to 0 when x is 0. So the function is discontinuous. Which means that f prime is undefined. But we are going to include that as a critical number. How else could you see from these formulas that the derivative's not defined at 0?
Derivative at the slope at 0 doesn't include.
Yeah. So if you look on the for x less than 0, if you look at what the slope is doing, when you plug in 0 here, you get 0. So on the left, the slope of your tangent line should be 0, should be approaching 0. But on the right, the slope of your tangent line is going to be approaching 2. So those slopes of the limits of the secant lines giving you the tangent line aren't matching. Because these slopes don't match. Slightly worse definition, or worse. No, it's discontinuous. Also, these don't match, which is a problem. Which is going to lead to a problem. But that's okay. We can do everything else still. How would we go on and do our derivative tests? Yeah, so you would set each derivative equal to 0 to find your critical numbers. Right? We have one critical number automatically because we know f prime is undefined here. But then we have to set this derivative equal to 0. Negative 3x squared equals 0 means that x is equal to 0. But, well, that doesn't really matter. Right? We already have that one. And it's not in this domain anyway. Over here, we set our derivative equal to 0.
Since it was less than or equal to 0, would it be in the domain?
Well, a derivative, not talking about one-sided derivatives, because we don't usually talk about one-sided derivatives, but you kind of have to be specific. A derivative is a limit, right? It's a limit of slopes to secant lines. So you can't have a derivative at one point. Like if you don't have something on the other side. So let me draw you a quick picture of this, right? This guy looks like x cubed on the left, I guess negative x cubed. So like this, but shifted up one. So like this, and it would usually keep going, but it doesn't because we cut it off. So this is on the left, and then on the right, this is a parabola downward. It goes through 0, 0. That out. So it should look something like this. But this guy is open here. So what I'm saying is even though f is defined at 0, f prime is not. So you can't put equal 0. F prime wouldn't be defined at 0 because the limit from the left and the limit from the right of the secant lines don't equal each other.
Okay.
So
I was curious how we had a less than or equal to in the f of x. And
yeah, no matter if the derivative existed at this point, if they met up, then you can, if they met up and the derivative was the same on both sides, if it approached the same thing, whether you did secant lines over here or secant lines over here, then I guess you can put an equal to there. But more what this less than means is that this formula is only valid for x less than 0 because you're undefined.
And if they did touch, it wouldn't have a derivative since it would be a sharp turn too.
Well, it's possible.
It's like the concavity would be on it.
Well, it's possible that you can put. You have to actually do the definition of derivative, but it's possible that I can give you. Let's do something like x squared if x is greater than, and then negative x squared. So what's this look like? This is a parabola if you're greater than or equal to 0. But then also a parabola if you're, a negative parabola if you're less than 0. So these are gonna meet up perfectly so that there's no problem when you do the limit. Try to do the limit of the secant lines here. It's going to be the same if you do it on the left or if you do it on the right. You're going to get the same limit.
Yeah, I was curious since it started going back up.
Yes, if we just moved this up, that would be a problem.
So it would be undefined.
Yeah, if you had a function, a piecewise function that comes in and like you're saying has kind of a hiccup where it comes down like this, but then maybe it starts going up immediately, f prime would still be undefined even though they meet because of the sharp turn. Yeah.
Okay.
But anyway, back to this guy here. So no critical number comes from this side. Critical number comes from the discontinuity in f. What about here? This looks like x equals 1, which is okay because that's in our domain for this derivative. So this is your second critical number. So then I will do my tests. 0 and 1. Then I'm going to have to test on the left. So let's put in -1. And then I'll put in 1/2. And I'll put in 2. Those are good test values. Into f prime. So when I put -1 in, what do I get for f prime? Negative, right? Because if you're talking about x equals -1, you're in this section. So you would plug -1 into x squared here. And then you multiply by -3, so ultimately you get a negative. When you test f prime of -1, you plug it into the left-hand side, and you will get -3 times -1 squared, which is negative. So that's where these negatives are. Then you have to do f prime of 1/2 for your second test value. Where do you put that guy? The right side here, right? So if you put 1/2 in here, you'll get -2 plus, I'm sorry, -2 times 1/2 is -1 plus 2 will be positive. So when you put it into the right equation, you end up with positive. And you put 2 in. Again, that's going to be on the right equation because 2 is greater than 0. So we'll do -2 times 2 plus 2 is negative. So we're increasing, I'm sorry, we're decreasing first, then we start increasing, then we start decreasing again. So we'll have a min here, a max here. So my increasing interval, what is it? 0 to 1? Looks like 0 to 1. Decreasing, -infinity to 0, 1 to infinity. Relative max comes at x equals 1, so y is going to equal, how do I get the y value when x is 1? Look at the original, am I going to plug it in top or bottom? Bottom, right? For x equals 1, we're talking x greater than 0. So we'll do f of 1, which will be -1 plus 2. And relative min will be at 0. X equals 0. Y equals f of 0. Top or bottom? Top, because that's where the equal to is. So you put 0 here and get out 1.
It would be like 0, 1.
That's what I got. At this point.
All right.